everyone. Today I will be discussing chapters 4, 5, and 6 in the textbook Extending Children's Mathematics, Fractions and Decimals by Susan B. Emson and Linda Levy. In chapter 4, we look closer into mathematical relationships. As a teacher, when we encourage students to use their own thinking to solve problems, we are asking them to look at the relationships between certain numbers, operations, and equations. These relationships are called fundamental properties. In this chapter specifically, it talks about using these relationships when teaching and learning about fractions. It is said that learning fractions helps students gain a foundation for learning and understanding algebra in the near future. When students are being asked to show their own strategies and thinking, it is called relational thinking. Chapter 4 focuses a lot on relational thinking and how important it is in mathematics. When looking at relational thinking, it is important for students to be tapping into the fundamental properties as well as their prior knowledge and schema to what they might already know. Relational thinking can be taught and expressed implicitly or explicitly. It is important for students to understand that numbers can be made up of other numbers and operations. When students understand this, they are thinking relationally. An example from the book is problem 8 plus 5 equals what? Instead of the students just counting to figure the problem out, the students can break down the numbers. First you add 2, then you add 3 more because 3 plus 2 is 5. Once students begin to understand that numbers are relative to other numbers, they will have an easier time understanding fractions. When looking at fractions, students need to understand that a unit of a fraction is the relationship between the whole and the two interconnected ideas that one unit can be divided into equal parts. This means that if something were to be divided up equally in an equal sharing problem, each person would get 1 n. Then if the shared parts were put back together, it would reconstitute into n times 1 divided by n equals 1. As talked about in previous chapters, equal sharing problems are key for students in understanding fractions because it gives them a chance to express their relational thinking and understanding and compare strategies with their peers. Teachers give students multiple group problems and they can benefit the students by reinforcing concepts of fractions. In the book, the problem shown on the screen was presented. What is the total amount of money spent on 5 stuffed bears, each costing $14? Do not write anything down. I found this extremely interesting. Every adult today uses relational thinking without even noticing. In this problem, in order to do it in your head, you might have broken up the number 14 into 10 and 4. This problem was possible to figure out due to relational thinking and understanding that numbers can be made from other numbers. Students are given math problems where they have had no previous teaching of a concept. An example shown in the book was first grade students given a problem to add fractions with unlike denominators. When the students were given the task, they worked hard and used their previous knowledge to solve a new type of problem. Children do not always need to be taught explicitly. However, teachers need to understand that their students' relational thinking and understanding in order to get them to the next concept is important. Once students understand fractions, they will be better off when learning about algebra and algebraic thinking. As expressed in the article, Interference of Instrumental Instruction in Subsequent Relational Learning, Pesek and Kirschner explain the importance of allowing students to give problems where not a lot of previous knowledge has been developed and allow them to engage in the semantic process and experience a new topic for the first time. In Chapter 5, it is discussed how teachers should explicitly teach relational thinking. In the chapter, there is a focus on a 5th grade class and how the teacher follows through with this goal. In Mrs. Perez's 5th grade class, they are focusing on fractions. The teacher is using equal sharing problems as well as multiple group problems. Mrs. Perez poses a question to the students which is written on the screen. I am making sub sandwiches for some friends. There will be 13 of us eating sub sandwiches. I want to serve each person a 1/4 of a sub sandwich. How many sub sandwiches do I need to make all together? After Ms. Perez reads the problem aloud, she walks around the room while students think and work in order to check for understanding and see relational thinking. If students needed help, she would stop for guidance. Miss Perez noticed as she walked around the room that two of her students were using relational thinking. Once all the children were done solving or attempting to solve this problem, she asked the two students where she saw relational thinking on their papers to share. Perez did this in order for her students to see other strategies, as well as communicate their thoughts with one another. This was a long class discussion. Having students understand that having an equation helps solve problems will greatly help them in the future when they switch to algebra. Equations help communicate their thinking to others. In Chapter 6, the authors focus on understanding fraction equivalences and order. In order for students to understand fraction equivalencies and order, students need to be able to think relationally and be able to express their strategies. Equal sharing problems are a great way for teachers to help students understand fraction equivalencies and order. Teachers use a strategy called open number sentences in order to teach about fraction equivalencies and order. These types of problems encourage students to use standard algebraic procedures, but instead use relational thinking and fraction relationships. Like stated in the article, The Harmful Effects on Algorithms in Grades 1 through 4 by Cami, it is important for teachers to allow students to independently think about the problems being put in front of them. Teachers should be encouraging students to think about what is being asked and come up with their own strategies of solving the problems. Open number sentences do just that. They are equations that have unknown values, which in turn promote awareness and understanding of relationships between fractions, as well as allow students to come up with strategies in order to figure out the unknown values. Once students have understanding of equivalent fractions and their relationships, they can complete harder problems, such as addition or subtraction word problems that contain unlike denominators and denominators that have common factors. For students to be showing that they are thinking about the relationships of numbers, teachers should be planning problems carefully, facilitating communication amongst the class, assessing the students, having the students reflect on the strategies that their peers are using, and understand the strategies that their peers are using. In conclusion, sharing strategies helps students make connections with their work, their understanding, and the relationships between numbers. The types of problems such as equal sharing, open number sentences, and multiple group problems promotes awareness of relationships within numbers. Having students share their strategies, like stated previously in chapters 1, 2, and 3, helps students understand other strategies and thinking that they might not have thought of before. It also allows them to draw conclusions from the problems. I will see all of you later for the next 2 chapters.